Welcome to Teddy Talks. In this video, we are going to look at an example of motion of connected particles of an incline. So this question says that two particles of mass of 5 kilograms and 3 kilograms are connected by a light elastic string over a smooth fixed pulley. Find Roman numeral 1, the acceleration of the particles, 2, the tension in the string, 3, the force on the pulley. So let's look at the solution. 1, how do we answer this question? We should begin by coming up with a sketch. We come up with a sketch. This is the pulley. We sketch it. It is a fixed pulley. Now they say there is a string here that is an elastic and light. And if you can ask yourself, why do we use light pulleys? Light strings. So this is 3 kilograms maybe, and this is 5 kilograms. Now the weight of this 3G will act downwards. The weight of this one 5G will also act downwards. Now in these strings we shall have tension in both directions. Now if these particles are to move, which is the direction in which these particles will move? 1, this body is heavier than that, so we expect this body to pull downwards, while this body will move upwards. Now the question is saying that we should find the acceleration of the particles. The fact that these particles being pulled by this, then the two particles must be having a common acceleration. That one should be noted, that these particles should be having common acceleration. So let us begin by considering motion of the 3 kilogram mass. Now if we look at the 3 kilogram mass, we are seeing that it is moving upwards. So the net resultant force that is given by Newton's law should be equal to the tension in the string minus the weight of this body. So here we are going to say that the net resultant force is equal to T minus 3G. Now we said from Newton's law, this force MA, which will be 3A, should be equal to T minus 3G. That is what it is giving us, implying that T is equal to 3 into G plus A. I have oversimplified, and I call this one equation 1. When we come to the 5 kilogram mass, we say for the 5 kilogram mass, the motion is downwards, meaning it is the weight of the 5 kilogram mass that is greater than the tension. So the net resultant force, which is given by Newton's second law, will be 5G minus the tension. So we said this in line with Newton's law. It is the mass times acceleration, which is 5G minus T. Therefore, our T is 5 into G minus T. Now, in our question, what do we need? 1, they wanted the acceleration. 2, they need the tension. 3, they need the force on the pulley, which is when they say the force on the pulley, we need the total tension that is acting on the pulley. We shall see when we are calculating. So now, since we are having our two equations, equation 1 and 2, these equations can be solved simultaneously, or we can just equate equation 1 to 3. So if we equate them, we're going to say that equating 1 to 2, because this is station, so it is 2, these two are equal. So 5g plus a should be equal to 5g minus a. Now what is our target here? Our target is making a subject of the formula. Let us see how we can proceed with this.